Hi, everyone. This is Diana Sinton, the Executive Director of UCGIS, and welcome to our webinar now today on Tuesday, December 10th. This will be our final webinar in our fall semester series. And I am happy to be able to introduce our speaker today, Brian Tomaszewski from Rochester Institute of Technology. We're actually concurrently simulcasting this webinar. Brian is presenting it live. And when I hand over the baton to him now in a moment, he will continue on with further introductions and explain to the live audience there where he is, who are all these other folks listening on the phone. So, Brian, it's all yours.
Okay. Hi there, UCGIS audience. As Diana said, my name is Brian Tomaszewski. I'm an associate professor here at the Rochester Institute of Technology. And I want to also welcome, we have a live studio audience here. This is, as Diana mentioned, this is being part of a series we have here in Rochester, New York, located in upstate New York, USA. It's a group called the Geographic Information Systems Specialty Group, GIS SIG. I've been part of this group for a long time. So let's look at a little website. Let's have GIS SIG get to meet UCGIS and UCGIS get to meet GIS SIG. So I will do that through just a couple look at some websites. Diana, can you see this okay?
Yes, I can.
Okay, great.
I can.
Okay, so what you're looking at here, and this webpage is the, these are sort of the counties of upstate New York that make up the GIS Specialty Interest Group. This group has been around for at least 20 years, over 30 years, right? So you have this really strong presence of GIS practitioners with some academics and students that are a very active local regional community. I remember long before I even dreamed of being a professor, I was a GIS practitioner. I worked for a company called URS, an engineering company in Buffalo, New York, and I was part of this group. So this is Justin Cole. I think will come up in a moment. Are you gonna say anything at some point?
I will say something.
Okay. Yeah. So Justin here is a real driving force. I think you're the president now, right? Congratulations on that. Belated, and so forth. Now, for those of you in the live studio audience from GIS SIG, people on the webinar, which is, let's see how many people we have. I can't really tell here, but this is the little tech gizmo that is connecting me to the 50 people. Oh yeah, attendees 50. Yeah, so we have 50 people.
Hey,
from
Brian.
Yeah.
Brian, I'm getting
Yes.
a message from people on the live side that they're having a challenge with audio.
Okay.
So I'm going to ask you to try the plan that we were going to try before, where you actually don't use the audio within the system, but call into that phone number.
Okay. All right. Do you guys mind if we take a quick technical break here? All right. So how does that work, Diana? Should I like log right?
Hold on. Now I'm getting a whole bunch of mixed messages, and
Okay.
oh my gosh, this platform.
I mean, I'm using my check 1, check 2. I'm using a pretty decent webcam.
Yeah, no, I agree. I hear you, and I'm getting I'm getting people who have dialed in are hearing the audio, and people who seem to be on the live site are having some problems, or on the website using the audio. So I would like I know that the audio is being recorded. The sound is being recorded. I can tell from my end of things that it's being recorded. So if you're out there listening to our webinar, do me a favor, try to check your own audio. We're seeing some conflicting things. Try to check your own audio, your own speakers, because actually, Brian, I think we're going to continue. We are going to continue. We're not going to switch anything. We're just going to keep going.
Let's just keep the train moving here.
Yeah, these live simulcasts are always really exciting.
Okay.
Continue. Thank you.
Okay. Yeah, and I think for the GIS SIG group, this is probably the first time one of these things. Have you done live simulcast before? Cool. So there we go. There's the RET leading the edge in innovation and so forth here. So anyways, this is the GIS SIG. Now, for those of you the live audience, I think an exciting thing about having one of these events as RET is, here's, the academic world of GIS a little bit. So the group that we've been hearing about is the University Consortium for Geographic Information Science, or the UCGIS. Has anybody ever raise your hand if you've actually ever heard of UCGIS? One, couple tentative hands. Most of you haven't heard of this. So the quick explanation is, in the academic world, when you do GI systems, if you take it up to the next level, it sort of becomes geographic information science. You look at the underlying theory, concepts behind the software. So, University of Buffalo, when I did my master's degree there was a guy, Professor David Mark, who he's retired now. He studied spatial cognition, how people think about geographic information, right? So it becomes these more kind of broader topics. I don't know who the audience is on the webinar. It could be a mix of graduate students who are studying GI science. It could be academic practitioners who are looking at more theory and concepts and so forth. But it's a really exciting group. Just looking at their website, oh, they're going to Hawaii. That sounds cool. They're going to be looking at emerging topics, artificial intelligence, data science, spatial cognition, visualization, and so forth. So basically various universities are part of this consortium, and RIT used to be part of the consortium a long time ago. We're trying to get back in this group. Okay, and then I'll give a plug to Diana, the woman who you've heard me talking to. She is the president of the UCGIS, and she's in Ithaca, New York, and so forth. Was that a good explanation of UCGIS?
Thanks, Brian. Technically, I'm the executive director, and Karen Kemp is our president currently, but okay. Thank you for introducing us. Thank you.
Yeah, of course. So that's just part of for you in the audience coming here, just learning about the bigger world of GIS outside of, Rochester, New York, Buffalo, and so forth, okay? So that's the two groups that are here, and at any point, if you have any questions, let me know. And why don't we get started then with the presentation I have for you. And I'll just kind of move the UCGIS, I'll give them that bottom corner of my space there. But here's the talk today. I'm going to talk to you about serious 3D GIS games for disaster resilient spatial thinking. There's a lot of concepts, a lot of ideas in there. And so I try to design this talk that it's a mix of some conceptual ideas, some practical things, kind of societal benefits, but also tech talk. As much as, maybe you're here because you want to learn skills, you want ideas, real tangible things that you can take back to your work with you. And hopefully I'll try to address all of that in this presentation. So, and yes, if we weren't clear, my name is Brian Tomaszewski. I'm an associate professor here at RIT, and my research lab is called the Center for Geographic Information Science and Technology. That's of my different affiliations. And this work that I'm talking about was funded by the National Science Foundation, and I'll talk more about that in a minute. Did you want to say something too before I start?
I think we're okay. I talked about that.
Okay. All right, great. Okay, thanks, Justin. All right. So here's what I want to talk to you about today. I'll talk about, serious GIS games. Maybe you know exactly what I mean to that. Maybe that sounds interesting, but you're not really sure what that is. I'll talk about this idea that I'm interested in disaster resilient spatial thinking, the NSF REU project. You can kind of learn about what's going on here at RIT, and then some results, and like I said, some tech talk. As I go further in my career, I actually am becoming less attached to using software, so I'm going to do my best to communicate some things I learned about from one of my students, but I still think it's some exciting things they did and some conclusions and takeaway points. Okay. So games and maps. Let's start with this as the opening of this presentation, right? Does everybody recognize this map, what this is? What is it? What's that? Risk, right. It's probably the original, one of the first games many of us played. And maybe the reason we got into geography or GIS is that, we really like playing Risk. I know when I was a kid, I loved playing Risk, right? And what's the classic strategies in Risk, right? Get all of Australia first, and you get 2 extra armies, and then you can invade Asia, get Greenland, and, it splits up the world. Now later, if you study map projections and so forth, anyone want to take a guess roughly what map projection this is? Anybody ever really thought about what the map projection of the risk board is? Anybody know or take a wild guess? Justin, you know? Yeah, it's the Mercator. It's rough. This is roughly the Mercator, right? Mercator map projection, which by the way is what's used. It's called the Web Mercator. If you do like ArcGIS Online, Google Maps, the Web Mercator, it basically stretches out the poles, so it makes Greenland look gigantic. Although in this particular one, they did a little better with Africa, but you know, you really distort the size of things. So in the classic risk map, especially the one I'm more of the 80s generation, you know, Greenland is this massive, gigantic land mass compared to, like, say, Africa, when in reality it's really not true, right? So a lot of us grow up, you know, before, you know, like I said, before we get interested in geography or GIS, we grew up looking at maps, and maps were fundamental to games, right? Either a geographic map or perhaps a hexagon. How many of you actually like to play computer games of some form or have over the years? Right? Even if you don't anymore, right? Hexagon maps, right? Those are really common. Even alternative worlds. They don't necessarily have to be based in reality. You can have a map of like wherever. I'm not much of a gamer, so I can't think of a good example off the top of my head. But games often have a spatial representation, a spatial kind of world that they exist in, right? And so I'll give a plug to RIT. So I'm now in actually what's called the School of Interactive Games and Media. So again, for some outreach for those of you coming to RIT, this is actually one of the strongest programs we have at RIT. And the Magic Center, the building, this beautiful new facility that you're built in, I think the acronym for Magic is like Media, Arts, Games, and Interactive Computing, I think. I don't remember. I'm doing bad citing the name of it, but if you know this whole building you're in, you know, multi-million-dollar grant from New York State to do interactive games, media, film, and so forth. So like RIT, this is one of our really strongest areas, especially in the college that I come from, computing and information sciences, and so forth. So so games and GIS, right? It's kind of, if you think about it, if you've never really considered the fit, it's a logical fit, right? So in the academic sort of research world, Ola Alfquist out of Ohio State, for those maybe you on the UCGIS webinar probably heard of him, he's been a real leader in research in this idea of geogames. You know, the title of this book they published, Game-Based Approaches to the Analysis of Geoinformation, right? How do you use games to understand geography, places, and so forth? Some of his early work was on what we call human environment relationships and games around that. Like if you have resources for a city, you have to make decisions about how much resource you allocate for something and so forth. I'm probably not doing it full justice and so forth, but there's been a lot of research in this. Anybody recognize what this is, this other graphic? Pokemon Go, right? That's what they might call location-based games. This has become a huge thing. The world around us as the gaming environment, right? So you go, everyone's got a phone, right? We all got our phones pretty handy close by. So looking for those Pokemon Go's and so forth. If you've kept up with the Google Maps API, they're actually now updating the Google Maps API to do more and more of this kind of stuff. You can build games right on top of Google Maps. And think of the possibilities, I mean, of having the whole world as your gaming environment. And that's why Pokemon Go has been so successful, right? And even at RIT, we've actually hired a new faculty member in IGM. This is his area, is location-based games, and how you can create play and experiences, but using the real world as the gaming environment, okay? And this is what my spin on this. I'm not a game person by background, but I've become interested in this. Then there's this idea of serious games, right? And the takeaway point on that is a game with a non-entertainment purpose, right? And sometimes it can drift, you know, it's kind of the line between what is a serious game and what is a simulation can kind of be blurred. Are any of you, I'm going to use disasters a lot in this talk, are any of you emergency management professionals? I don't know if anybody from that domain is here. Nobody? I don't know. Do any of you ever do simulations or trainings at your jobs? Yeah, what do you do?
I just retired from the county, but we do grenade preparedness and you have tabletop exercises.
Right.
hazmat or whatever.
Did you ever think of it as a game?
Well, the exercise, you're walking in, you don't know what scenario they've dreamt up, so somebody has made the scenario that they're expecting you to play.
Right.
Different than escaping or something like that. Or
Yeah.
building an environment for you to work in.
Right. Yeah. So if from UCGIS, if you didn't hear that, the woman in the audience talked about how she does table talk exercises for training. In Rochester, New York, we have a very large nuclear power plant that's not too far away from here. So a lot of our county officials and others spend a lot of time worrying about, basically, as they should, if that thing were to have a meltdown. I just watched Chernobyl on the airplane recently. So yeah. Right. So serious games uses the ideas from games, and I'll talk about gamification a little bit in just a moment, but with a non-entertainment purpose, right? So this was a classic example I use. It was produced by UNISDR called Stop Disasters, a disaster simulation game, right? So this is looking at the scenario might be, you're a coastal city and you have limited resources. How do you mitigate against a tsunami or flooding or so forth? But it's a game, right? So you get a score, you have motivation, you have a narrative you're playing against and so forth. And that's the idea of a serious game. And you've probably done these before, whether you know or not. Maybe Risk could be considered a serious game. I mean, the game of Risk is sort of life and death. It's conquest. I mean, it's kind of fun. It was fun to take over your brother or sister and have them out of the game. But, ultimately, Risk is a war game. And look at all the things on it. It's very detached. We don't really think of death and destruction in the game Risk, but in some sense it is a serious game, and so forth. Okay. So serious GIS game. So what I try to do is lead you up to this idea of what my research has been about is, combining all these ideas together. So how do I take, the power of GIS, spatial analytics, spatial representation, right? That's what GIS is good for. How do I put a narrative behind that, right? Games typically have a narrative. You're a character on a quest. You're in a scenario or something, and then how do I gamify it, right? Raise your hand if you've ever heard of the idea of gamification. You guys have heard of gamification? What's gamification? Well, yeah.
It's when you add game-like elements into a non-game-like scenario in order to make it more engaging and or to increase its retention value.
Yeah, perfect answer. Perfect answer. You thought you were just going to come to this talk and have to sit here and making you do the work, right? Yeah, so gamification, just like we heard from the audience, is taking the ideas of games and adding them to some other kind of scenario to make it more engaging and more interesting. So here at RIT a few years ago, we had a team before I was in the department, led by Professor Elizabeth Lawley, who's actually a GIS SIG keynote speaker long time, at least 9 years ago. But there was this idea of, I think it was called Just Press Play. And the idea was, on college campuses, we want the students to go out and explore the campus, right? College students typically will go to their classes, their dorm, maybe the library, and that's it. You want them, though, to explore the whole campus. So they gamified exploring around campus. So if you went to a certain spot, you would get points and you would get some kind of reward and some benefit. Kind of like, I don't know if this, I guess Foursquare is still out there. I don't know if it's as popular as it used to be, but that's kind of like, a couple from many years ago, gamifying going visiting places. If you go visit all kinds of things, you get some kind of reward or incentive, right? So that's the idea of gamification, right? But then with serious games, games can have learning outcomes, right? So we were interested in this research, how we could develop learning outcomes for a real life scenario. And in this case, in just a moment, I'm going to talk about, the slide went ahead, disasters, right? So those are sort of the ideas that went into this research project. And let me talk to you now about disaster resilience. So this is becoming a really important concept nowadays. If you accept that climate change is a reality, and every year we're seeing more and more and more bigger, stronger, more intense disasters, right? We're coming to the end of 2019. What were some of the big ones we had this year? We had in East Africa. I can't remember what that one was called offhand. Then we also had the one in the Caribbean. You guys remember that one? Hurricane, yeah. What was that one called? I'm blanking on the names of these things at the moment. I want to say Hurricane Irma or something, but we have Katrina from 2005. We have Harvey that I'm going to talk a lot about. Every year, more and more and more and more bigger disasters are happening. So this idea of resilience, right? Have you guys heard of the United Nations Sustainable Development Goals, UN SDGs? That disaster resilience has been part of that. How do we, with this quote, the ability of a system or community to withstand the impacts of an event and recover to an acceptable or existing or improved state comparison to what was before, right? And so that's a really pretty broad term if you think about it. You could have the physical resilience, just rebuilding infrastructure, the sort of social resilience, how do people become more adaptable and able to cope with these kinds of things and so forth. And I'll use one example. Here's right in our own backyard, right? Lake Ontario. I'm actually a Lake Ontario resident on the short water, and this was actually a picture from my backyard, right? And so I had some study. I had my students this summer look at this. For those of you in the UCGIS audience, just for some context, here in upstate New York, we are right on the shore of Lake Ontario, and the lake level has been, especially this year, was at a record level, causing flooding. And it happened also in 2017, and it's an interesting issue to study in terms of disaster resilience because it's multifaceted, right? You have to build physical resilience, like this picture here with the bulldozer showing building up shoreline resilience. You have temporary solutions like sandbags, and this is what's called an aqua dam. But then you have this one, right? Plan 2014. This is the big controversial issue of policy, right? A lot of people in upstate New York believe that the reason the lake is flooding is because of a water regulation policy. Some people don't believe that, but that's the topic, right? So do we, how can we improve our resilience? Do we get rid of Plan 2014? Do we stick with it? Do we build better barriers and so forth? And as part of the research then, how do we teach people to sort of think spatially about disaster resilience, right? And that's what I'll talk about next. Spatial thinking. Raise your hand if you guys have heard of spatial thinking before, especially in the audience, right? In the GIS world, I mean, it doesn't always necessarily, you don't really think about it, but this is what GIS does. GIS tools, it enables spatial thinking, right? And in the UCGIS audience, this was a really important report. These images come from 2006. Learning to think spatially was a really kind of groundbreaking report that really tried to lay out what spatial thinking is and how GIS technology helps enable it. And the basic ideas really distilled in their essence the concepts of space, right? Two-dimensional Cartesian XY grid versus latitude, longitude, spherical coordinates, right? It's still the same space, but it's just a way that you conceive of that space, right? And, this is something you learn about, right? I remember like in, for me, it would have been probably like math class in high school that I probably learned about XY coordinates. It wasn't later until I did GIS that it kind of came back, right? And probably like in high school social studies class, I first learned about latitude and longitude, right? As GIS people, if you understand the basics of a map projection, right? You're basically taking latitude, longitude, spherical coordinates and you're flattening them out and transforming them over. It's still the same, the same spot on the Earth. It's just a different way that you conceive of it, right? And so that leads to the second idea, representations, right? Map projections. How many of you in the audience actually really deal with a lot of different map projections in your day-to-day work? Does that come up a lot? A couple people? I mean, if you're really zoomed in on like the town of Brighton, you probably don't have to do a lot of like crazy map projections, but kind of this goes back to risk, right? Here's the Mercator map projection, right? And as best as you can see it, with my mouse is being a little weird, but notice even how, if you guys can see it out there, both on the webcast and the audience, look how the lines of latitude are really just kind of get stretched out, right? It's just a different representation. That's why Greenland looks so big. That's why Antarctica is going to come and gobble the rest of the Earth up, sort of, just because of the way that it is represented. as opposed to an equidistant conic projection, right, where it's centered on the North Pole and so forth. It's still the same Earth, it's still the same land, it's just a different form of representation. And that's, you know, another important aspect of spatial thinking. And then spatial thinking reasoning, right? When I've done lectures on spatial thinking, we do sort of spatial reasoning all the time, whether we knew it or not. How long does it take to get to RIT? Well, I got to get my phone out and figure out. And I often think of distance more in terms of time than the actual distance. How many of you, when you came here today, thought, oh, I've got to get there because it's going to be 5.7 miles? You didn't say that. You said, oh, it's going to take 17 minutes from the office to get here, right? That's what you're more concerned about. So it's a spatial reasoning, but you have to restructure it in terms of time. And again, you don't really ever think of it that way. It's automatic and so forth, but it's all spatial thinking. And ideally, you know, you guys are all GIS professionals. You're all expert spatial thinkers and so forth. You know that when you go hiking, when all the little contour lines are close together, that's actually going to be pretty steep up the hill. Where some people might go hiking and not, you know, if they don't understand how to read a contour map and what it represents and how to reason with it, they can potentially run into trouble, right? Okay. Let's see. Okay, so again, kind of combining a bunch of ideas all together. So I talked about disaster resilience, I talked about spatial thinking. So what I was interested in, you know, disasters are inherently spatial. They're place-based, they operate at multiple scales, and they're fundamentally geographic. I mean geography, like people and the places they live in. You know, it's pretty straightforward, but it's also really powerful to think of it that way. I don't know any of your personal experiences, you know, but probably all of us has been affected by some form of disaster, whether we knew it or not. You know, I mean, I grew up in Buffalo, New York. I feel like in my day, I remember as a kid, the blizzard of '77, if anybody gets that reference, and so forth. You know, I've built a sense of resilience up against snow and so forth, but if you're not, you know, flooding on Lake Ontario, that's something we don't really have memory of, and a lot of people on my street were really affected by that when it happened, even in the last couple of years. So combining, you know, the ideas, the concepts, theory of spatial thinking with GIS, you know, I would argue is vital to disaster management. Critical thinking, problem solving, decision making. And it still is a gap. It still is a problem in this area. And I took this, when I was putting this presentation together, I went back to my, I'm going to talk about my NSF project. I use this as an argument in my proposal. Hurricane Sandy 2012, you had people that drowned in Manhattan that were living in apartments, you know, in the basement. And we could argue that had there been a better understanding of where people lived, where they were, you know, below sea level, their vulnerability, there could have been better, you know, spatially oriented planning to perhaps have saved people's lives in that case. And think of countless examples like this. I was thinking of this too, bringing it back around here. This is a map one of my students made over the summer because we looked into perceptions of Plan 2014. But when I was thinking of this presentation, you know, spatial thinking in disasters, just even basic map reading, you know, when you hear a lot of people down here, so again, for the UCGIS audience, here's Rochester, New York, here's Toronto, you know, the flooding in you know, here in Monroe County where we're located was all right around here. How many people, I'm just guessing, and maybe they do, maybe they don't, but how many people that are all, you know, angry about Plan 2014, are they really thinking of the whole bigger picture that's involved in this? You know, Lake Ontario, you know, I don't have all of the Great Lakes, but you have to think spatially at a different scale. You have to think about the whole Great Lakes system. You know, all of the Great Lakes are really high right now. If you read the reports, Lake Superior is high. It all flows one way, right? So I would, you know, you might try showing people a map like this. Are they aware of the dam? This is what's holding Lake Ontario back, and this is where, this right here is the spot where all the controversy is. Like, how much water do they let out? I use the comparison of like a water spigot. You know, how much are they opening up to let it out? The Ottawa River, you know, this is also adding water into the overall system. So they're holding water back in Lake Ontario because more water is coming in from here, and they're trying to avoid flooding out Montreal, right? Those are the basic facts of the situation here. But again, we might, as this particular audience, and maybe our web audience takes those things for granted. You have to build people's spatial thinking ability to think about systems level thinking beyond just our local area and so forth. Now, yeah, if your backyard's flooded out and your house is threatened, sure, that's the local reality, but trying to understand it in the bigger system is also, I would say, just as equally important. And that's why I think this is an important research topic, building disaster resilience spatial thinking skills. I think if you understand the bigger picture of things, it gives you a better insight in how you potentially can build resilience up, okay? Any questions so far? Making sense of all these different ideas? All right, I'll try to bring them together now into this research project. So the NSF REU project. So what is NSF? NSF is the National Science Foundation. Have you guys all heard of the National Science Foundation? I always tell people Bill Nye the Science Guy. He's probably one of the more public faces of it. The UCGIS audience, I don't know who's in there, but if any graduate students that are listening to the webcast, if you've never heard of the NSF, this is a really important U.S. federal agency that funds basic fundamental science. So this is your U.S. tax dollars at work, basically. And they have a program called Research Experience for Undergraduates, REU, and it's one of the flagship programs that the NSF has had for many years. And I was fortunate enough, I was able to get funding, and the project was called GIS for Disaster Resilient Spatial Thinking. So that's kind of the build up to what I've just been talking to you about. Okay. And what we did in this project was research on serious games for disaster resilient spatial thinking using GIS. So here's kind of a wordy slide, but this is, when you write NSF proposals, maybe for those of you on UCGS, or maybe in the audience, the NSF funds basic science. They don't fund applied projects, right? They don't fund, we're going to go map out watersheds in Rochester, New York. There has to be a bigger science question and so forth. So like, what spatial thinking competencies are relevant to disaster resilience, right? That's the question. That's the bigger science. Which tools are best for connecting resilience with spatial thinking? And what are the best practices for building games? I'm not going to read the text here, but right. So that's just a way you have to think about when you go after one of these proposals and so forth. And it takes time, I think, to train your mind to think in this mindset. I know that when I was a practitioner, it was definitely a process I had to go through, especially when I started my Ph.D., of getting out of, using tools for direct problem solving. You have to understand, what is the broader science, how does it just advance knowledge, and then the practical outcomes come from that and so forth. And although we do have, although it's tricky because the NSF likes to see products and practical outcomes, so then it's almost like some of you probably write proposals for funding from the state, or some of you, is that part of your work? Or you're in the private sector and you respond to proposals, right? You have to learn to play the game sort of what to write and so forth. It's the same thing with the NSF. Okay, so what we did in this project, we had 16, this is from 2 years, we had 2018 and 2019, we had 2 summers of funding. So we recruited 16 undergraduates, 8 per summer, and every year we had, this past summer and last year, we had some local representation. We had MCC, both years had a student, and we had SUNY Geneseo the first year. But the students came from all over the country. It was great. We had students from Oregon. We had students from Iowa, Nebraska, from Clark University, if you know that school. It's a really good geography school. We had Penn State came, a whole wide variety, and students from a lot of different backgrounds. In this cohort here, we had one guy was actually like a game student. We had another young woman who was interested in emergency management and GIS. We had other that were more straight geography. We had political science. It was a really great interdisciplinary mix of students. In addition to that, my co-PI, Dr. Dave Schwartz, who's not here, he had his own funding for cooperative education or co-op. If you know RIT, this is one of our real signature things we've had since the beginning, as far as, at least, I don't know how far back co-op, that's like the RIT's like signature thing, the co-op. Have any of you ever had, in the audience, had co-op, RIT co-op students, right? Yeah, a couple of you raise your hands, right? So RIT is very big on sending our students out to get jobs and do stuff. So we hired some for that. So we had this really great interdisciplinary mix of students, and I'll show you some of the outcomes that they, were able to derive in just a moment. And then as part of the story I'm telling you, we also had this Harvey NSF supplement. So another little thing to file away, especially in the UCGIS audience, if we have any early career faculty or graduate students, whenever big disasters strike, the National Science Foundation will sometimes put out special funding calls related to disasters. And they did that with Hurricane Harvey in 2017. NSF has a mechanism called RAPID, which is designed for, as the name implies, rapid, quick research designed to go capture data on something that's ephemeral. So, for example, if you really wanted to study the immediate aftermath and recovery after a disaster, the National Science Foundation could potentially fund you to go down to, say, Houston, Texas, right after the thing is over, to capture things that in a couple weeks may go away, right? I don't know, I'll make something up. You're interested in first responder interactions with vulnerable populations within the first 2 weeks of a disaster, right? So that's only going to be there for a little while, so you need money to go down there quickly and get it, because before you know it, it's gone. But they call it high risk, high return. So it's risky. You may go down there and find nothing, but if you do go down there and find something interesting, it could be transformative. That's a good NSF word, transformative research, right? Because you were able to go down there, or who knows, you're able to go down right during the wildfire and look at the conditions on the ground before they started cleaning things up and so forth. You captured an important data set, right? So that's an NSF Rapid. So that's what, for Harvey, they had something similar kind of like that. They put a call out for proposals to study Hurricane Harvey. And so I applied for it, and I was able to get a little bit of extra money that I attached to the NSF REU project, and that then became sort of the case study focus of the project. So it was kind of I guess interesting. So I had students in Rochester, New York, spending the summer in Rochester thinking about Galveston County, Texas, which is south of Houston. But the reason is because we had this. And it was actually pretty exciting because it gave the students a real project to work on, and we actually went down there. In the third point, we did field work in Texas to kind of validate the work they were doing. And it really is a great case study of disaster resilient spatial thinking. I don't know, memories are starting to fade a little bit on Harvey, but did anybody ever hear did you guys hear the story about how they had to redo the rain maps? The rain maps for Harvey, it rained. That's the whole reason, just real basic. Harvey, all the flooding came from rain, right? It wasn't from storm surge. It was so much rain came down in such a short amount of time. The existing map scheme couldn't fit what they had. They had to redo how they drew rain maps because there was so much of it. And then Galveston County, I forgot to put an overview map in, but you have Houston, and then you have Galveston, which is just south of Houston, and there's Galveston Island. Has anybody heard of Galveston Island by any chance? No one's heard of Galveston Island. It's pretty well known kind of resort area because it's right on the Gulf and so forth. But and then Hurricane Ike got hit pretty bad about 10 years ago. So that was the Harvey supplement. Okay, so what did we actually do? So the research activity, I had students do a lot of literature reviews on topics of serious games, disasters in general, and spatial thinking. I'm not going to really talk much about that stuff. I didn't really think that would be of much of interest, but we did come up with a theoretical framework of combining serious games, disaster resilience, spatial thinking, and GIS, and we're working on getting a journal paper out from that. But more nuts and bolts stuff that did, especially for undergraduate research, we had them compile GIS data sets. So it was a good case of, when I teach GIS, one of the first things I try to teach students is how to just find, I call it, data in the wild, right? Just going out in the wild world of the web and finding data. Even New York State, the New York State GIS Clearinghouse and Cougar, Cougar seems to be changing, and that's what task in itself is, just finding data that's relevant and using it. Creating game narratives, and that kind of tied into getting empirical data that I gathered down in Galveston and using that in the game narratives. I don't know if anybody remember me from 2018, I think. I remember I gave the keynote at the local GIS SIG conference. I don't know if any of you remember that or were there. But so I played a clip from that of a woman describing her Harvey survivor experience, right? So I had these really compelling stories of people having to leave their houses, put all their things in a kayak, wade through black water to get to an interstate, and so we took all of that to create a narrative of a game, because remember, games have narratives, and then the actual building, the actual tech work of building the game was also part of the part of what we did and so forth. So let's the end results are 2 games, and that I'll spend the rest of the talk now kind of on this stuff, hopefully keep it interesting for you. The first one is called Project Lily Pad, and I learned about lily pads were areas in Galveston County where think of what a lily pad is, right? It's where a frog or something sits on a pond. So the lily pads became areas that where the ground was high enough that it wasn't flooded. So during Harvey, people would kind of congregate on lily pads. They would hop in boats and whatever, and they get dropped off at lily pads. And so we built sort of a narrative quest game around that idea of a lily pad. And I'll show you a demonstration of it in just a minute. This is just a screenshot, okay? And in the game, we use Dickinson, which is in Galveston County, as the game environment, right? So a serious game, a location-based game with, life or death kind of consequence, but all driven by GIS. And this is an earlier version of that game. And I'll show you, like I said, I'll show you a demo in just a moment for that one. And then in 2019, just this past summer, they built a different game called Project EOC Emergency Operations Center, where they used the scenario of an emergency operations center manager. Raise your hand in the audience if you've ever been to the Monroe County EOC. A bunch of you have, right? So yeah, Tim from the EOC was kind enough to give us his time, and we sent the students over there in the beginning of the summer, and they got a lot of inspiration on how do you gamify being a project EOC manager, right? And if you know disaster management stuff in the United States, like the NIMS and the Incident Command System and all those kind of terms, we had one student who was really knew that stuff, so we incorporated that kind of domain knowledge, again though with 3D GIS stuff in this narrative of responding to various events happening in Galveston County. And from the screenshot here, you can see, something happens, you have to deploy resources, and you ultimately get a score. So again, it's gamified. You're gamifying the project, emergency manager kind of experience and so forth. And that's what this was about. And I'll show you a demo of that in just a moment as well. So that's kind of the highlight. And then I'll do, for this next part now, I'll show you some results and we'll do some tech talk. I figured maybe that, I didn't know what you guys would like to see in a talk. So for those in the audience, raise your hand if you've heard of Unity. Most of you have heard of Unity. Okay. Do you know Unity from your work or just from, how do you know Unity? I didn't know if you guys would know what Unity. Yeah. Games? Yeah, I mean, is it like you make games or?
Yeah.
Okay, I just didn't know how widespread in the GIS world Unity is, so that's why I don't mean to, So, right, we're not going to talk about how to make ninjas. I mean, that does sound cool, but for those of you, especially maybe in the UCGIS audience, if you've never heard of Unity, I myself, I wasn't really honestly aware of what Unity was until a couple of years ago. But in the game world, it's like the ArcGIS Pro. it is the tool. It is what they use. So a lot of the students in RIT's IGM school that I mentioned earlier, this is what they invest a lot of their time in. This is what they get jobs doing. It's really hard to see with all these lights. There's the Ninja, right? But it's a pretty complicated environment. It's a pretty heavy-duty tool, and so forth. And so what one of the students figured out how to do, and I'm please interrupt me or correct me. I'm not a full-time tech person, so if there's a better way to do it, that's great, and you can shout it out. But they did the workflow of OSM, actually, yeah, OpenStreetMap to, I didn't put it in here, QGIS to ArcGIS to Esri City Engine to Unity. And I thought I would kind of just go over that if something to consider. Because it's pretty cool to start really rethinking what we can do with geographic data and how we can interact with it and make it interactive using tools like Unity, okay? And I was really impressed that a lot of you knew what Unity was. I just didn't know.
Play more games.
Play more games. There we go. So this is from all I did for this part is I took I can send you this links, but this is a YouTube video that one of my students made in 2018 from the REU, and this was actually Scott Williams from SUNY Geneseo Geography. He was a really, really, really sharp student, and let's go over the workflow. Raise your hand if you guys work with OSM data a lot, OpenStreetMap data. Not too many of you, huh? You all know what OSM is, though? Okay. OpenStreetMap, right? The Wikipedia of maps, free open content data. So what we did for this, to create Project LilyPad, he went into the OSM website, he selected an area of interest, and then there's an export function. Okay, and again, there's going to be multiple, any tech task, there's going to be multiple ways to do it. I'm just showing you one possible way, right? Maybe somebody's texting me telling me I got it wrong. No, I was kidding. Okay, so then once you go into OSM, you probably won't be able to read it. You see the .osm file. So you get an OSM is what OpenStreetMap is going to send out. Okay, and the way that we did it, and maybe you guys can correct me. I haven't seen Esri having a native way to bring in. Do they have that now?
Well, it's a plugin.
A plugin, right?
And I think it's still desktop.
Right. Right. So there is like a plugin for probably, ArcMap or Pro or.
There's ArcMap, but I haven't seen the update yet.
Right. So it's still a little clunky, I think, to get native OSM data into Esri. Are most of you Esri users? Raise your hand if you're Esri, what you basically make your living off of, right? Most of you, right? How many of you make your living off of QGIS? All hands go down, right? A little bit? Okay. How many of you just use QGIS? Couple. How many of you, do you all know what raise your hand if you've never heard of QGIS. That's okay too. A couple people. Okay, good. Well, that's what we're here to learn about. So I think it's Quantum is the original. Quantum GIS, but no one calls it, they just call it QGIS, right? So if you want one little nice sharp takeaway point, QGIS is the free and open source sort of version of ArcMap, ArcPro. I actually myself in my own career, I just finally this year really took the time to really learn QGIS more. Like I said, I'm not a tech person anymore. I don't have much time available for learning new software. I mean, I have to do that for my job, and because I love teaching and I have to keep myself up to date. But QGIS, in my personal opinion, and maybe some of you, or maybe when we get to questions in the UCGIS audience, can correct me. I found there's a lot of similar. They do a lot of the same things pretty well. My personal opinion is, QGIS, Esri, just the user experience is better, especially ArcGIS Pro. I mean, just think about it. Esri is $1 billion company. They throw a lot of money at building a software product. You'd like to think, although we all get frustrated when it crashes and stuff, but spend some time doing the same tasks in each software, and you'll just, maybe because I'm getting older and I want less stress in my life, but I like just opening up, clicking a few buttons and having it work, not having to load 5 plugins and it's a weird interface, and it gets the job done in the long run, but you know, I'm looking for more convenience. That's just my personal opinion. But that was a long sort of diatribe on what we did in this part is we took the OSM file and brought it into QGIS because there just was better native support. It just works, where you can just bring it right in. You know, Justin mentioned about the plugin for Esri. I've tried that. Sometimes it works. Sometimes like you're supposed to be able to do direct editing of OSM. That doesn't really work. I mean, I've you know, I give that to a student to figure that out and move on with my life. But in this case, so all we did, we used QGIS. So look it up. It's a really good tool for a lot of things. We brought that in to get it. Basically, our goal here is just to get a shapefile, right? Old school shapefile. Still work with shapefiles, everybody? Right? Yeah. The de facto standard that seems to never go away, but because it does the job, right? So you take from OpenStreetMap, bring it into QGIS, run an export to shapefile, and then you could continue on. But what we did then was we went back to our old friend, you know, in some sense even a little outdated now. I finally have made the switch myself. I only use ArcGIS Pro. I've learned to. It's great software. You know, it gets the job done. In fact, I'm finally all my teaching. I've gotten rid of ArcMap, and even my book. I did a second edition of my book. I have no reference of ArcMap in there. I have one sentence in that ArcMap is going to be around for a few years, but the future is ArcPro. It's been the future for a long time, and those of us in academia sometimes we're slow to change over. How many of you are out in the audience are still just use only ArcPro? No hands go up. How many of you use ArcMap? Most. Okay, interesting. Okay, so maybe. What's that?
About 80%.
Pro. Interesting. Okay. Yeah, I mean, I think there's even less and less now things that ArcMap could only do that Pro couldn't do. I know the one that I discovered a few months ago was exporting models as Python scripts. Pro can do that now. That was one thing I remember that only ArcMap could do, but now they're catching up and so forth. So so think about it. If you're not using Pro, and this is even for the UCGIS audience, if you're not using Pro, think about it. It's where things are going. So that's maybe another takeaway. And there's plenty of tutorials and trainings out there. I know it's tough in the with your work to switch, because if ArcMap's doing the job, why, you know, if it isn't broken, don't fix it. Cost and so forth. And I understand that. But anyways, shapefile to GDB. So what Scott shows us in this video is you take the shapefile that you created originally from OSM, and all he's going to do is put it into a geodatabase. Okay. From there, now I'm not an I've hardly ever used CityEngine, so I'm just going off of this thing. But CityEngine is really, really cool. How many? Raise your hand in the audience if you work with CityEngine. No one? Anybody from Bergman here? Bergman? Does Eric Brady doesn't work for Bergman anymore, does he? No. So a couple of years ago, I actually knew Eric Brady. Those in the web audience won't know what we're talking about. I'm talking about some local things here, but I remember a few years ago, Eric Brady and Bergman was doing some really interesting work with CityEngine and 3D modeling. I don't know, are you guys still doing that, or?
Not at present, but we still.
Okay, yeah. So in private sector GIS, sometimes there's companies that, you know, engineering companies that really get into like 3D rendering. So if you've never heard of CityEngine, it can create cinematic quality like cityscapes and representations. I've heard secondhand that it was even used to make like Hollywood movies and stuff. It's a heavy duty, powerful tool from Esri, right? And, you know, I'd like to do more of it in our teaching. Justin, that's something we can talk about, you know, like, but we used it in this research to help build our game, right? And so what we did was we took the file geodatabase and brought it into CityEngine because it's an Esri tool. So fortunately, their two softwares can talk to each other. And you can even see, let me turn the lights off just so you can see the screen a little better. You know, right off the bat, you're starting to get, you know, it's a CityEngine. It's designed to make 3D simulations of city environments. You're starting to see a street network appearing. And so if you watch this full video, Scott talks about then you have to clean the data up. I mean, that's like any GIS, really. it's always about the data, right? Cleaning it up. And then this was this was kind of interesting. In ArcGIS Pro, you get a little bit of this kind of stuff. You get rules and textures, which I don't know if you guys, how well you can see it over here. Like basically assigning to render out buildings, right? You know, certain heights of the buildings, certain textures. So if you have just like, say, a blank sort of kind of polygon that's extruded, then you can stick facades on it and so forth and start to really build really cool three-dimensional environments, right? And so in the video, he talks about doing that and so forth. And this is just a little screenshot of what he started building. He used Ithaca, New York, because that was his hometown, but you know, this can be anywhere. And so that's kind of the cool thing, right? OSM, free and open source data that you can then kind of pipe it into some of these other tools to start doing things with it. And so this is kind of that part. And then from there, what he did was, and this is something that, again, I'm being upfront about my own technical limitations, but export, right? And this was the key discovery, I know, in 2018, was when they figured out how to take the data from the Esri tools, from City Engine, and get them into Unity, right? And so it was the wavefront OBJ, the wavefront object. Any of you ever heard of this object? Or I had never heard of it, but this was able to communicate with City Engine. And again, maybe somebody in the UCGIS audience has a better way to do this. I'm just communicating the way that we did it. And so basically, an export, right? It's a particular format that City Engine can or that Unity can read. And so from there, from the wavefront OBJ, you bring it into Unity as a model in Unity. And if you watch the whole video, he talks about setting up different scenes and so forth. But that's a screenshot now of, you can kind of see behind it. Here's City Engine, and here it is inside of Unity, and then it's ready to sort of start becoming a game using the game building mechanisms of Unity. I mean, and then from there they handed it off to the co-op students. Our REU students were not game students, but the IGM students, this was what they were really focused on doing, is then actually building the engineering of the game. Okay. All right. So let's see how we're doing on time. 12:30. How are you guys doing? Everyone all right? Okay. I think I've been at it for an hour now. Whoa. I will now put my life on the line, and I'll do a live demo, which can always be dangerous. Diane, is everything going okay in the UCGIS part of things?
Yep, we're good, and looking forward to watching you play it. Give us a chance at the end of, I'm going to encourage people on our end to, if they've got some questions, to type them into the question space.
Absolutely. I think we're probably done. And it looks like we started at 50 and we're at 59, so it looks like people haven't lost people.
We're good.
A couple people trickled out of the room here, but that's all right. All right, so let's see. Oh, no, that's the webinar. Okay. So we've now combined, and I'll show you where you can find these. We've combined the two games into one thing called Navigate Disasters. And you're going to watch Professor Brian stumble along trying to play a video game here, which I don't do. I mean, I actually really like games. I just don't really have time for it anymore. But okay, let's see. All right, so here we go. Okay. So this is the welcome. So they modeled an EOC room, and I'm going to use my arrow keys. I'm going to walk over to the desk. Okay, and I think, yeah, click, whoop. It's got to turn, boom, okay. And I'm going to play, let's look at Project Lilypad first. So it's a little dark on the screen there, but that's Project Lilypad, the first one I talked about. This is the quest game. Confirm selection, and then I've got to go walk over here with my arrow key. And so you get some feedback. Take control of a first responder before and during a Texas flood of Galveston County. And this is life or death, right? This is a serious game. You're dealing with trying to save people who are due because of flooding, okay? And I think I have to walk to the little table here and click on the lily pad and hit the go button. So we've got it, now the sound's coming on. Play it. Okay. Okay, here's a little feedback. It's standard kind of game interactions if you play kind of first person. So it's a first person game. But again, I'm not going around with a gun killing people or anything like that, even though that could be its own bizarre form of entertainment. But we're going to save lives here. It's serious. It's life or death. And it's also spatial thinking. Okay. Okay, click on a sticker. Okay. So here's the narrative, right? When you play games, you get a narrative. So I'm going to, I'm a disaster management professional. I got to deliver medical supplies. Now here comes some real, I'm at Texaco gas station, westbound entrance of highway, marked by the sticker. And I got to put stickers on the map as I move around, okay? And then I got a dispatcher, right? So I'm out in the field and there's somebody on the walkie-talkie or whatever sending me info as I move through this, through the world here, okay? Oh, okay, all right. We've got the rains a little loud there. I'm just going to turn it down. Right, but even just let's just look at what's happening here. So you're in a virtual environment. Those slides I showed you, this environment was built using that workflow. So they went and got OpenStreetMap data for Dickinson. They brought it into, what did I show you? QGIS to ArcGIS to CityEngine to Unity. And now that's the real, if you were to go to Dickinson, this is the real world, right? So here's my little, here's my dispatcher now. Is already telling me what's going on. Your first stop is Dickinson High School. They're setting up a shelter for the flooding. There's a tent outside the school for you to drop off your supplies. Travel, so here's spatial thinking now and reasoning. Travel along Highway 517 until you run into Baker Drive on your left. Okay, so here's navigation directions and so forth I've got to deal with. About halfway down the road, the school will be on your right. Once you arrive, speak to the volunteer and so forth. Okay. Okay. They added this new thing, the flood water's rising. They did put grid coordinates in. That was a kind of a new addition, but let's just see what it's like to play it. So now here I go, start to run. And again, I don't know how good my computer is for this, but you get the gist of it. Because I've got a lot of things, I've got the webinar going and stuff too, but right, here's some street signs to tell me where it's going. Okay, where do I have to go again? Okay, well, check it out. I do get, now if I hit M, and this is something I didn't, there we go. So there's my mission, and there's my map, right? So they updated, they put the grid coordinates on, so I've got to deliver to high school 517, turn left. So I'm right here. So I've got to go here, right? So that's basically the turn left onto Baker Drive. So this is a pretty easy one, right? I have stickers. I can change the map around and so forth. But I've got to use my spatial thinking to do this, right? So off I go running. And again, I don't know how good my computer is going to be to play this. It's usually not so slow motion. Diana, how's it coming out on the webcast? Is it really super slow?
Well, it's a good thing there's not a wave of water behind you, but I think it's working. We get the idea.
The proof of concept. Okay, because I don't think, because it's going so slow.
How long is it going to take you to get down to where you need to go to the high school?
That's what I'm wondering about. Let's see. Yeah. Okay, well, let's talk about the value of this book. You know, so I'll talk a little bit about evaluation, I think to save time, but we did do some feedback on this. Think about it for the idea of situation awareness, just getting people aware of a, you know, responders coming in. That's what happened during Harvey. You had a lot of external people that came into the area that had to navigate around. In this game is way easier than the reality that was faced. Like, there's street signs, there is not floodwater, there's visible landmarks. Like, we've talked a lot about improvements of this world of this that you would make it a lot more difficult, you know. All right, well, just, you know, because it is playing a little slow and for sake of time, but you guys get the gist where I was doing. I'd like to show you the saving the people, but let's just let's go back to the menu, show you a little bit more. Let's give you a quick taste of day 2. So back to the idea of the narrative, a big part of it was this now, although we got it factually wrong, the idea of the Cajun Navy. Do you guys ever heard of the Cajun Navy? Anybody know what that is from Harvey? Cajun Navy. They were a bunch of people from Louisiana who came to help out in Texas, because during Hurricane Katrina, a lot of people from Texas came to New Orleans and Louisiana to help out, and there were memories of this. And it's a whole interesting side story. The Cajun Navy came like fully armed, and so we had these like lots of guns and, you know, but anyways, so in this one, then you similar, it's still a quest, but just to show you again some of what they did. Now you're in a boat, and they modified this one. They really looked at some of the issues of the water and so forth. So we've got to go and get some stranded people, rescue some survivors on a lily pad, and in this one yeah, it's playing a little slow here, but now I'm in a boat. And this one that you can see how they really, they did more to really improve like what flooding would look like. But even this, from when I've had disaster management people tell me, this looks too clean. Like, you can see the road. Have you ever seen pictures? It would be black, horrible, disgusting water that you would not, you know, and so forth. But that's the example of that one. And let me give you a quick taste on of Project EOC. Let's see. Oh, wait, no. Quit that. Okay. How are we doing on time here? Yeah, let me quickly show you Project EOC, which I think should play. Oh, whoops. Sorry, I got stuck on the table here.
So much reality.
Okay, so that's the context. That's where this happens. And okay. Lot to read here. Okay. Yeah, so in this one, you're just kind of waiting for things to happen. See how there's a clock ticking down here? Potential aid request available. And so forth. Well, let's see. So basically you have to just kind of wait for things to happen in this one. And I don't know if this is getting in my way. But you can see here too, just for sake of time, they did a really nice, the students did a really nice job. Again, this was also with OpenStreetMap data, City Engine, and so forth. So family and need evaluation. This is all supposed to train you on reading coordinates. They're at 21894123. So, and these are, what do they call them? National grid coordinates is what, because that's what disaster management people use. So you got to first kind of find it. 210, I think that's going to be. Oh man, brush fire. I don't think I'm good at this game because I can't find anything.
You're gonna have to learn triage.
I guess so. But yeah, we need to fix this. But that's the gist of it because we're kind of running out of time here. But basically then once you do find one of these things, you then deploy your assets. You send police out, volunteers, and the situation unfolds because again, time is ticking down and so forth in that one. So, okay. All right, so let me just kind of wrap things up here then. Okay. Yeah, so like I said, we did do, we did do some evaluation. This was in so what we did was the last 2 years, we went down with that Harvey supplemental funding. We went down to Texas. This is in the Galveston County EOC. And this is actually the Monroe Community College student, and this is an emergency management professional, and she was giving us feedback, and she's telling us like, this looks good, but you wouldn't see things. You know, we got a lot of really good sort of domain knowledge of how to fix this and make it improve it, because from an NSF perspective, the broader impacts, we want this work to be relevant to society. I mean, there is those more science questions, but ultimately, how do you, the sort of taxpayers, how do you benefit from this work? And I'd like to think that with these games, we can give them to working professionals, students, citizens, and they can learn more about disaster resilience, spatial thinking of their communities, and so forth, right? And, let's see. Yeah. So just to kind of wrap things up there, in conclusion, today I talked to you about, introduce serious games, the combination of serious games, GIS, spatial thinking, and disasters, right? It's a lot of terms, but hopefully I've tried to demonstrate how combining those kind of 4 areas, we're able to do that through a student research experience, through an NSF research experience for undergraduates program. So for those, especially those in the UCGIS audience, if you are an undergraduate on this webinar, consider applying to one of these things. If you're a junior, new faculty member or established faculty member, consider applying to the NSF to get one of these programs. They really are, you get a lot of really amazing students, and hopefully even in my small way, I've demonstrated the possibilities that can be created. And ultimately for both the in-person audience and those of you on the webinar, just maybe rethink just a new way of thinking about what's possible with GIS, what's possible with open data, what you can do with 3D, and the exciting possibilities of games, right? Making the world interactive, even if it's not a game, perhaps bringing your content into Unity and just navigating through the environment. Tools like ArcGIS Pro can do animation and so forth, but I think adding gamification, right? Really visiting things, giving rewards out, having some kind of scenario, a narrative, and so forth behind it. I think that really can get us to rethink what's possible with our data and our technology and how we think about it. And then ultimately, like I said before, just the broader impacts for society. Ultimately, what this is leading to is to try to save lives when disasters occur, mitigate the impacts from disasters, and so forth. And I think as geographers, as GI scientists, as professionals, I think that's what we're really well positioned for. So I just want to, again, straight up acknowledge the NSF funding for this project. And with that, sorry. If you want to find out more about this project, We have several other videos that we've created. You can download the game that I showed you. It's all on this webpage. I know it's not really graphically stunning, this view of it, but the link is down there and so forth. And with that, I'll take your questions. Thanks a lot.
So any
Brian, thank you from the online side too. Let me know when I can. If you're listening to this webinar, feel free, please, to post a question into the question space, and I'll convey that to Brian.
Okay, thank you.
Thanks to Brian for his, the talk and stuff. If there are any questions here. Okay.
All right.
So lunch first is going to be in Carlson, which is the building right across from us at 11:55. So there's food there already. So it's ready. There's the cover papers should be coming out fairly shortly for the GIS conference in April. So check your emails for that, as well as Town of Greece also has some internships that they're looking for, so I'll be posting that. And I have some flyers, and John's in the back, who's from the Town of Greece. Okay, so thank
All right. Diane, any questions on your side? Oh,
Yeah.
Thank you. Okay. We have some questions from the web audience if you guys want to listen.
Yeah,
go
so Brian, a few people have wondered about whether the games themselves can be accessed. So it sounded like you could download them, or are they web based? So it's something that you would download and install. It's a desktop.
Yes, exactly. Yep. So if you go to this web page, you'll find a link to the GitHub, and here's what it looks like when you download it. You'll get a zip file, and it's just an executable that you run on your desktop.
Okay, excellent.
Yeah.
Another person posed this question: if this project were 100% successful, would one outcome be the creation of games like this that people actually play for fun?
Well, I mean, I guess it depends on what you define as fun. Sure. I mean, it is fun.
Pandemic and stuff like that.
Fun. It would be satisfying knowing that you saved lives, that you responded quickly, that you're a good decision maker. So I guess the answer could be yes.
I guess one thing is being able to use realistic, real OSM data. So do some things in real geographies.
Well, that's what we did. That's absolutely what we've done. And then the real question, a thing that Dave Schwartz has always been interested in is real time. Could you render these environments out sort of in real time? So as something's unfolding, could you somehow, with enough power or whatever, pull data in real time, render things out on the go?
Mm-hmm. Right. Do you so did you get the sense when you were talking with the person down in Houston that games like this would be effective as a return on investment if organizations or company used games like this for training, for professional development?
Yeah, so with Project LilyPad in 2018, we got a sense of that with that one. The one lady from Galveston County said that, as I alluded to, they got a lot of people from out of town, like the National Guard was showing up, and just getting people oriented. So say you've got like 10 National Guard guys who are waiting to go out, who are not from around, have them play the game and learn the area. That was one feedback on that. Another from this year, a guy who actually was a responder during Harvey, he was really interested in LilyPad. He's like, oh, could you fix this and modify it? So I think, with more maybe artistic visual rendering, making it more connected to what really it looks like on the ground there, more of a simulation, I think that would show value. And then the other one, Project EOC, that I briefly showed, we demoed that over Thanksgiving this year. And the guy there was also, the different guy was very interested in that as a training device, as they spend a lot of money on multi-agency coordination trainings. And so again, for the people in Rochester, New York, Guinea, how many different organizations would have to respond on that?
It's difficult to coordinate all those people, so
Right.
you could play the exercise first.
Exactly.
And you're not just all walking in off the street
Right.
trying to do this exercise.
Exactly. Did you hear that?
A little bit.
Yeah, so the lady in the audience said, if you could play this scenario ahead of time before everybody gets together, that could provide value. Even just the tabletop exercises themselves, I imagine, are costly. You've got to schedule them. Everyone's got to take a day off from work and go. Could this potentially be a surrogate replacement complement to something like that? That's another thing that, you know, because we really, in EOC, we focused on the management of it versus the first one where it was more the response, kind of the quest game.
Right. Right.
Yeah.
Last question from our side. I think this might be the last one right now. Have you looked into the development of any virtual reality or either VR, virtual, or augmented reality, AR, to do
I
with
haven't,
this as well?
that sounds awesome. The building I'm in right now has a whole huge studio to do all that stuff. We are going to reapply for the REU, so that could be something that I think goes into this. Sounds great. We haven't at the moment, not directly, but I know there's more of that. I mean, Pokemon Go is the often cited example, but I know that Esri has a new experimental tool that's like a AR thing that allows you to put your Esri data into an AR environment. That's something I know just in my own work I want to look into. So I think it's a great idea. Yeah.
Super. Okay, thank you everyone on the recording. Yes, this whole session was recorded, and when you registered for this webinar, you'll be getting an email. I think it goes out within the next 24 hours. It includes the link to this whole recording. If anyone there live in Rochester would like the link to this recording, get in touch with Brian or with Justin, and we can make sure that you get the link as well to the recording. Thank you very much, Brian, for sharing this with us, and for the people there on the ground in Rochester for helping coordinate it.
All right, great, Diana. I'm really glad I know we talked a lot about this. I'm glad we were able to work it out.
All right. Thanks very much, everyone. Bye-bye.
Bye.